Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you all doing well. Dear students, this lecture is for grade 7, boys and girls, both wings, subject science. And in this lecture, we will continue chapter number 9. The topic is dispersion of light. This is my 25th lecture, and I am your lecturer, Mrs. Saira Jamal. Today we are going to discuss about the critical angle. What is critical angle? When light rays pass from a denser medium to a rare medium. Denser medium, I told you, is water or glass, to a rare medium, which is air. So when light passes from water or glass to air, what will happen? They bend away from the normal. From rare medium to denser medium, then the light ray will bend towards the normal. But in this case, as the light rays passes from a denser medium to a rare medium, then reverse will take place and the light rays will bend away from the normal. In this case, the angle of refraction is greater than the angle of incidence. If the angle of incidence is gradually increased, a stage will come when maximum refraction occurs and the angle of refraction becomes 90 degree. Definitely when the light rays passes from a denser medium to a rare medium, so the denser medium will have a specific angle with the normal, or in other words, you can say that the incident ray will make a specific angle with the normal. By changing the angles of incidence, the angle of refraction will also change. Then we will reach at a time or at a moment when the angle of incident will be that that much value it will have, which will give the angle of refraction at 90 degrees. Here the refracted ray becomes parallel to the surface of the refracting medium, and the angle of incidence, for which the angle of refraction is 90 degree, it is called critical angle. What is critical angle? The angle of incidence for which the angle of refraction is of 90 degree is called the critical angle. You can understand this from the image that this is a normal line, and you can see that the incident ray, it falls on the medium. This is a slower medium. Slower medium means the denser medium, and outside is the faster medium, which is air. Air is faster medium and rare medium, while the water or glass is a denser medium. We can say that the incident ray falls on the surface of the medium and it is bending, and it is bend away from the normal. When it moves outside from denser medium to rare medium, you can say it, the refracted ray is also making an angle with the normal, and this refracted ray bends away from the normal. The refracted ray bends away from normal. When the incident ray will arrange in such a manner, you can see incident ray is changing angle with the normal until the refracted ray is making an angle of 90 degree. It is making an angle of 90 degree with the, we can say, with the medium. So the angle of incidence for which the angle of refraction is of 90 degree, you can see here that the this refracted ray, it is making 90 degree angle with the normal. So the angle of incidence for which the angle of refraction is of 90 degree is called critical angle, and we represent the critical angle by theta c. So this is normal line, and this is slower medium in denser medium, which may be glass or water, and the faster medium is air, because air is a rare medium. Now again you can see that the incident ray is moving. It will arrange in or it will make at a specific angle with normal, where the angle of reflection is making 90-degree angle with the normal. So that angle of incident for which the angle of reflection is of 90-degree, it is called, this angle is called critical angle. This is angle of reflection and this is angle of incident. Angle of incident with normal, angle of reflection with normal. Total internal reflection. When light passes from glass or water to air, means from denser to rare medium, same like in the previous case, this blue part is water or denser medium, and outside is a rare medium. So you can see here that when light passes from, this is a source of light. When light passes from denser to rare medium, it bends away from normal. This is normal. And you can see the light bends away from normal. This is angle of incident, which the incident ray is making with normal. And this is angle of refraction, which the refracted ray is making with normal. When we will change the direction of torch or the source of light, then you can see this is the incident ray in this case, and the angle of refraction is making 90-degree angle with the normal. So the angle of incident for which the angle of refraction is of 90-degree is called critical angle. This is critical angle, which we represented with theta c. C means critical angle. If you further change the direction of light, now you can see that the light is bending in the same medium. And I told you that the bending of light or reflection of light in same medium is called reflection, not refraction. Refraction is when it passes from one medium to another. But in reflection in the same medium, in denser medium, the light will move or strike the surface and will bend inside the same medium. So this type of bending of light is called reflection, and it is also called total internal reflection because the reflection takes place in the same medium. And when this happens when the angle of incidence is greater than critical angle. When angle of incidence is greater than critical angle, in that case, the angle total internal reflection will take place or the refracted ray will bend in the same medium. So this process is called total internal reflection. So when light passes from glass or water to air, denser to rare medium, it bends away from the normal. But when angle of incidence is greater than the critical angle, this is angle of incidence, and if it is making an angle greater than critical angle with normal, then the angle of reflection or the angle of or the refracted ray or the angle of refraction, it will be the reflection will takes place in the same medium, that is in the denser medium, and this phenomena is called total internal reflection. So when light passes from glass or water to air, it bends away from the normal. But when the angle of incidence is greater than critical angle, the light rays reflect in the same denser medium, and this phenomena is called total internal reflection. Total internal reflection takes place only when light passes from a denser medium to a rare medium. These are the conditions, and these conditions are compulsory. If light passes from denser to rare medium, then the total internal reflection will take place. Not from a rare to denser medium, from denser to rare medium. And second condition is that the angle of incidence of all rays must be greater than the critical angle of that denser medium. The angle must be greater than critical angle. If the angle will be greater than critical angle, then total internal reflection will take place. If angle will not greater than critical angle, then no reflection will take place in that case. So these two are the important conditions. And you can see that the angle of incidence with normal, and this or in case of critical angle of incidence should be greater than critical angle. If you want the phenomenon of total internal reflection, then the angle of incidence must be greater than the critical angle. C is for critical angle. Now you can see that by changing the direction of light, this is a torch or laser light, and this is a tub which contains water in it. By passing the light in that medium at a different positions, you can see the angle of reflection in different cases. You can see it over here. By changing the direction of the light, as you are moving the laser light, so it means that you are changing the incident ray. By changing the incident ray, you can get different reflected rays. Applications of total internal reflection. Many optical instruments use the principle of total internal reflection for their working. One of the instrument is binocular. Binocular, you can see in this image, the critical angle for glass is around 42 degree, and when light enters a right angle prism, it makes an angle greater than the critical angle. So it causes total internal reflection to take place, and a binocular uses reflecting prisms to see distant objects. You can see here that in binocular different spectrums or different prisms are used, and those prisms actually work on the phenomena of total internal reflection. And by the phenomena of total internal reflection, we can see the distinct object clearly or easily in binocular or by using the binocular. Now, this lens through which we can keep our eye to see is called objective lens. This is objective lens, and these are the prisms. This one prism is here, one is here, and one is here. There are prism. This is the eyepiece. Sorry, this is the eyepiece through which we are keeping our eye, and this is the objective lens through which we can see the object. So this is the eyepiece, which is also called ocular lenses, and these are called objective lenses through which we are watching the object. And as I told you that the prisms are attached or are arranged in the binocular, and through that prisms we can see the distant object or the far away object clearly. The function is that when light passes from this through this pathway from the objective lens, when light passes, it will fall on this prism, and then after falling this prism, it will make a refraction, and that refraction will give us a wave or a beam of light which then fall on another prism, this prism, and finally from this prism it then goes and fall on the you can say eyepiece, and then by this way the distant object looks short to us or close to us, because this is due to the total internal reflection. And again they say that the lenses or the tools which are used in the binocular, it contain or it works on the process of total internal reflection. Then periscope, we can see objects which are higher than our eyes. You can see here the object which is even higher than our eye, or it is at the other side of the wall. Object to be seen here areas you can see by using this periscope, and periscope is also used in submarines to see the surface of water. A simple periscope consists of a tube at the end of which are fitted two right angle prisms. You can see this is a tube, simple tube, and it has two prisms. One prism is here at the base and another prism is fixed at the top. So two prisms are over there inside the periscope. The first prism turns light coming from the object toward the second, and the second prism turns it to our eye. The first, when the light enter, it falls on this prism, and it will then make it straight on second prism, and then we can see the object clearly. So the second prism turn it to our eyes. The prism use the principle of total internal reflection. Periscope are used in submarines and tanks, etc. Light from we can see through this periscope to this opening, which is the eyepiece, and the light fall on this first prism, which is at a 45-degree. Then it will bend to the other surface, and you can see the light from the tree will fall on this prism. Prism will direct it on the inner prism, and then from the inner prism to our eye, and then we will be able to see the distinct objects. Prisms. A prism is a block of glass with three rectangular and two triangular surfaces. A right angle prism has 190-degree and two 45-degree angles. The critical angle for glass is about 42-degree. When light enters the prism, it will reflect it internally. It will reflect it internally. You can see this is the prism, and this glass prism, when light fall on this prism, and it is reflected back in the same medium. It does not pass out, not from the denser to rare medium. Over here you can see from denser to rare medium it entered, but then it reflected in the same medium, in the same rare medium, rare from rare to rare. So this is called total internal reflection of the light ray. And the prism is consist of three rectangular surfaces. You can see this is one rectangle, this one is one rectangle, and then we have this rectangle, the downward, which is called B, and then the C, A, B, and C. This one is A. This one is A rectangle, this one is B rectangle, and the downward, and this upward is the C rectangle, rectangular surfaces. And a right angle prism. This is a right angle prism because you can see this line is making an angle of 90 degree with the base or with the surface. So, and the other two angles, this angle is 90, this angle and this angle are of 45 degree. So the critical angle for glass is 42 degree. When light enters the prism, it will be reflected internally, and when it will in fact reflected internally, it means that it also works on the phenomena of total internal reflection, because in total internal reflection, the light, the angle, incident angle is greater than critical angle, and then the total reflection will take place. Instead of refraction, reflection will take place, and the light will bend in the same medium. Then we have mirage or mirages. So what is mirage? Have you ever seen water on the road ahead while traveling on a hot sunny day? Have you experienced this? In a hot sunny day on a road when you are moving, the road is perfectly dry, but it looks that the water is present on the road. But when you get there, the close to that area, you'll see that the water was never there. It was just like we can say, just imagine water over there. What you saw was a mirage. A mirage is an image of some distinct object which appears to us due to the refraction and total internal reflection of light. And this is just fake water, not real water. The air higher up is cooler than the air near the road. You know that the air which is above in the upper layer, it is cooler than the air which is near the road, because the sunlight when falls on the road, it will make the roads very hot, and the air which is close to the road, due to that heat of sun, the road become very warm or hot out. So it will also make the air warmer, and you know that the warmer air is lighter in weight. So the light rays near the road, light travel faster when it reaches the warmer air. So the light rays bend as they travel downward due to refraction. Near the ground where air is even more warm, the light rays travel almost parallel to the ground but continue to bend in other direction, which is called total internal reflection. When we see this travel in a straight, when we see these bending light rays, our brain assumes that the rays have traveled in a straight line, and these rays seem to us as reflecting from water. As a result, we see a mirage or desert travelers often observe mirages. So this is just fake water which we see, but when we get closer to it, there is no water. It means that this phenomena by which this mirage work is again reflection and total internal reflection. Fish eye view. What is fish eye view? We have studied that when light travels from one medium into another, its speed changes. When light travel from, as I told you, fastest medium is the rare medium, and the slowest medium is the denser medium. So when light travels from one medium into another, its speed changes, and which causes the light to reflect at the boundaries. As light travels from water to air, it will bend away from the perpendicular to the surface, or bend away from the line which is called normal and is perpendicular to the surface. When the angle of incidence is greater than 48 degree, all the light is reflected back into the water, and when fish looks up, it will see reflected view of the sides and bottom of the pool, while directly above it see compressed view of outside world due to refraction. Now you can see that from the when the light passes from the eye of the fish, you can see that it passes up, and those light when it passes up, they will go when they passes up, what will happen? Those light rays, they will refract out, means from denser medium, when they'll go into the rare medium outside the surface of water, into the rare medium, into the air. So you can see that the ray is reflected away or bending away from normal. Same is at this case, that the rays are moving away from the normal. And by changing the position, you can see if the fish changed position, now you can see the angle of incidence is this one, and the angle of reflection will be 90 degree. Straight line is over there. This is 90 degree at this side and 90 degree at this side. So at this, in this case, that when the fish see the surface, it will see all the things above the surface. But if the fish changes its position, and when the angle of incidence is greater than critical angle, so you can see that what happened, the reflection takes place, which is called total internal reflection. No reflection now, because the light is bending in the same medium. So we can say that the reflection of the light rays takes place, and this reflection is called total internal reflection. We have studied that when light travels from one medium into another, its speed changes, which causes the light to refract at the boundary. As the light travels from water to air, it will bend away from the normal, and normal is the ray which is perpendicular to the surface. And when the angle of incidence is greater than 48 degree, all of the light is reflected back into the water, which is called total internal reflection. When fish looks up, it will see all the areas above the surface of the sea or of the water or aquarium. But when reflection will take place, or total internal reflection will take place, at that time the fish will not be able to see the things or the object which are outside the surface or above the surface, the fish will see only the things which are present inside the sea, because it eyes show the total internal reflection in the bending of light in the same medium. So the fish will be able to see all the things which are present in its surrounding, inside the water or inside the aquarium. It will be able to see that. So this was all about the fish eye, and we discussed the total internal reflection, mirages, all about those. The other topics, inshallah, we will continue in our next lecture. Till then, take care. Allah.